Hi viewers. Let's have a look into the ASME B16.20, standard for metallic gasket for piping flanges organization and details of various metallic gaskets. ASME B16.20 in its single chapter along with its table and figures provides scope and various requirements and standardization for the metallic gaskets. Scope defines the coverage, quality systems, references, and relevant units used in the standard. Subsequent para is dedicated to ring joint gaskets. They are widely used in the oil and gas and petrochemical industry, in valves and pipe work. Choice of material may be determined to suit higher temperatures and aggressive media. Ring joint gaskets are metallic sealing rings suitable for high pressure and high temperature applications and are fitted in ring groove type flanges. Ring joint gaskets are designed to seal by initial line contact or wedging action between the mating flange and the gasket. By applying pressure on the seal interface through bolt force, the softer metal of the gasket flows into the microfine structure of the harder flange material, creating a very tight and efficient seal. Two types of ring joint gaskets are mentioned for metallic gaskets for pipe flanges as per the cross-section visually octagonal and oval. The oval ring fits the round and flat bottom ring groove flange, while the octagonal shape fits only the modern flat bottom groove flange. The octagonal cross-section has a higher sealing efficiency than the oval and would be the preferred gasket. However, only the oval cross-section can be used in the old type round bottom groove. With respect to flange size, pressure class, and appropriate flange standards, ASME B16.20 identifies ring joint gaskets as R, RX, and BX ring gaskets. R-type ring joint gaskets are available in oval or octagonal cross-section and manufactured in accordance to API 6A and ASME B16.20 to suit API 6B and ASME B16.5 and ASME B16.47 Series A flanges. These gaskets are used in pressures up to 10,000 psi. The octagonal type has a higher sealing coefficient than the oval, therefore being the better gasket of the two. The oval type is the only gasket that will fit a bottom groove. Flanges with flat bottom V-grooves will accept either style. Style RX is a pressure-energized adaptation of the standard style R gasket. The RX is designed to fit the same groove design as a standard style R, making the joints interchangeable. The modified design uses a pressure-energized effect that improves the efficiency of the seal as the internal pressure of the system increases. The RX has an increased height and utilizes the internal system pressure to energize and improve the seal as internal pressure increases. Some RX sizes have a pressure relief hole to equalize pressure both sides of the sealing faces. RX ring gaskets are similar in shape to the standard octagonal ring joint gasket, but their cross-section is designed to take advantage of the contained fluid pressure in affecting a seal. RX gaskets are designed for pressures up to 15,000 psi. RX types of gaskets are more costly than standard oval or octagonal rings, therefore not as popular. RX type gaskets perform excellent in 6B flanged blowout preventer stacks, which requires the additional mass of the RX gasket to support the higher pressures with higher vibrations and heavier weights of these units. The RX type RTJ gasket is manufactured in accordance to API 6A and ASME B16.20 to suit API 6B and ASME B16.5 flanges. BX style RTJ gaskets are manufactured in accordance with API 6A and are suitable for use in high pressure API 6BX flanges, where pressure rating ranges up to 20,000 psi. These gaskets allow virtual surface-to-surface contact of the flange faces, which means that the gasket is fully trapped on both the inner and outer diameters. All BX gaskets incorporate a pressure balance hole to ensure equalization of pressure that may be trapped in the grooves. All BX sizes have a pressure relief hole to equalize pressure across sealing faces. API B16.20 further provides material requirements for these ring joint gaskets, including hardness requirements. The hardness of the ring should always be less than the hardness of the mating flanges to prevent flange deformation. Detailed requirements are presented in Table 1, which provides the maximum hardness in terms of Brunel and Rockwell B scale for various specified ring gasket materials. Following to this are the marking requirements, which provides the marling identification code for the ring gasket material and is indicated by relevant examples. Dimensions for API ring joint gaskets and grooves are covered in ASME B16.20 and API 6A. The dimensions for the ring joint gaskets are standardized and are shown in Table 3 to Table 8. Spiral wound gaskets are used for applications that require an increase in temperature and pressure, and high loads on the flanges. The most often used semi-metallic gasket for high-pressure joints is the spiral wound gasket. Depending on the flange type and application, a wide variety of configurations of the spiral wound gasket can be used. Spiral wound gaskets are designed to maintain a seal in flanged joints under severe fluctuations of temperature and pressure. Spiral wound gaskets are suitable for a wide range of operating conditions and can be adapted to suit almost all applications. The gaskets can seal fluid pressures up to 250 bar and temperature range of -200 degrees Celsius to in excess of 450 degrees Celsius. Spiral wound gaskets are manufactured by winding an alternating combination of a metal strip and soft filler material. The spiral wound gasket depends upon the mechanical characteristics of a formed metal spiral strip, rather than the compressive virtues of more traditional gasket materials. This makes it particularly suitable for low or fluctuating bolt loads. Graphite is usually used in the sealing strips or fillers, although sometimes other materials such as PTFE may also be used. Stainless steel is always used in the windings. The completed gasket is fitted into a steel ring of specific thickness. When the gasket is fitted into a flange and the bolt load is applied, flange closure is governed by the outer steel ring of the gasket. To further improve the pressure rating of the spiral wound gasket, a steel ring may be added to the inside. This also protects the windings, particularly the filler, from contamination or attack by the product. Gaskets are color-coded to help expedite the selection and identity of the gaskets one needs. The color on the outside edge of the centering ring identifies both the winding and filler materials. The metallic winding material is designated by a solid color. The filler materials are designated by color stripes at equal intervals on the outside edge of the centering ring. ASME B16.20 specifies the size and pressure class requirements. Dimension and tolerance requirements in accordance with Para 3.2 and Table 9 through 14. Construction requirements for spiral wound gaskets are detailed in Sub-Para 3.2.2 of B16.20. Metal joining, centering ring, inner ring and gasket compressions are detailed in various sub-paras of Para 3.2. Material requirements, marking and color coding for the metal jacket and filler material is detailed in Para 3.3 and Table 19 of the standard B16.20. Jackated gaskets. Metal jacketed gaskets, as the name suggests, consist of a metallic outer shell with either a metallic or non-metallic compressed fiber filler. The filler material gives the gasket resilience, while the metal jacket protects the filler and resists pressures, temperatures, and corrosion. Frequently used with heat exchangers, although they are more and more often replaced with corrugated and grooved gaskets. Best suited to sealing flat surfaces of gas pipes, heat exchangers, cast iron flanges and autoclaves, metal jacketed gaskets can be useful when dealing with irregular or faulty flange rims. They require mechanically processed flanges, high bolt loads and a correct alignment in order to provide an efficient sealing. Metallic gaskets can come in different styles like double jacket, single jacket, or solid metal. Soft compressible filler material can be flexible graphite, PTFE, or non-asbestos compressed sheet type. The design of a metal jacketed gasket also may require different shapes, and the styles mentioned above can be made to a variety. The standard filler is normally sufficient for applications up to 900 degrees Fahrenheit. Other soft fillers are available for higher temperatures or special applications. ASME B16.20 specifies the size and pressure class requirements, design requirements including jacket thickness and filler thickness. Dimension and tolerance requirements in accordance with Para 4.3 and Table 21, 22, and 23. Material requirements for the metal jacket and filler material is detailed in Para 4.4 and Table 24 of the standard B16.20. Marking requirements for easy identification along with suitable examples are provided in Section 4.5 and Table 24 and 25 of the standard metallic gasket for pipe flanges, that is B16.20. Grooved metal gasket with covering layer. Grooved gaskets have proven themselves in all industrial applications. These gaskets are found in industrial power plants and in the primary circuits in nuclear installations. Used either between flanges or in heat exchanger units in nuclear applications, power plants, petrochemical and chemical industries in the most difficult applications such as superheated steam, high-pressure hydrocarbon or chemical service, as the gaskets are used in applications where high pressures and temperatures are maintained and consequently high bolt loads need to be controlled. For flange protection, the solid grooved metal core gaskets are normally used in conjunction with a covering layer with soft conformable facing materials bonded on both sealing surface faces of either PTFE, graphite, aluminum, silver, thus providing total protection to the flanges and a secure seal even at low minimum surface pressures. By this way, flange is completely protected from the grooved profile of the gasket. Size-wise, grooved gaskets can be manufactured in wide range of sizes, from a few millimeters to a diameter of 3,600 millimeters. These gaskets are suitable for use in class 150 to 2,500 service and hence can resist to pressures of up to 350 bar and temperatures of up to 800 degrees Celsius, depending on the sealing material type. Some of the advantages of grooved gaskets are: depending on the metal core, the gaskets can be refurbished, the only type of gaskets that can be used again after having been refurbished. ASME B16.20 specifies the size and class requirements, dimensions, and tolerances requirements through its various tables. The construction, welding and centering ring requirements are also detailed out in paragraph 5.2 and tables 26 to 28 of the standard B16.20. Material requirements for the covering, core, and the centering ring along with the color code is detailed in para 5.3 and table 29 of the standard B16.20. Marking requirements for easy identification along with suitable examples are provided in section 5.4 and table 30 of the standard metallic gasket for pipe flanges, that is B16.20. So in a nutshell. Now let's have a look at the appendices of this standard. It comprises of 2 mandatory appendices and 1 non-mandatory appendices, which covers dimensions of gaskets in U.S. customary units, references, and quality system programs. Altogether 30 tables from table 1 to 30 is tabulated in this standard. These tables, as stated earlier, provides the hardness, dimensional, material, color coding and various other requirements. ASME B16.20 refers to API and ASME standards, in course of stating the requirements. ASME B16.20, standard for metallic gasket for pipe flanges, is referenced by number of other standards visually: American Petroleum Institute, American Society of Mechanical Engineers, British Standards, Canadian Standards Association, NASA, Norma Brasileira Regulamentadora, National Fire Protection Association (PD), and Process Industry Practices. The effects of pressure and temperature fluctuations, the temperature difference across the flange face, along with flange rotation, bolt stress relaxation and creep, demand a gasket with adequate flexibility and recovery, to maintain a seal under variable working conditions, and hence one of the requirement of any gasket is the ability to recover under variable loads. Sizing of spiral wound gaskets. Of utmost importance, regardless of the type of flange facings in use, gaskets must be sized to ensure that the sealing element is seated against flat surfaces. If the spiral wound element intrudes into the flange bore, or extends beyond the raised face outside diameter, damage will result to the gasket, and ultimately failure will occur. The windings of the gasket can become unwound when the gasket intrudes into the flange bore. Possible severe damage to components and equipment can occur when the system is pressurized. The gasket will grow radially during the compression phase, and it is essential that proper clearances are used for grooves and recesses to compensate for this.